So here we're optimizing another quantity. We're optimizing the area of a given region. So just have to make sure we write expressions and we write explanations algebraically, corresponding to what we're given in English. So let's read what we're saying, what we're told. So first we have 100 feet of fencing. So the total amount of fencing that we have is limited to 1,000 feet. We're going to enclose a rectangular playground. Start by sketching. And the question actually asks you to make the sketch. So rectangular playground. We're going to subdivide it into two smaller playgrounds by placing fencing in the middle. Doesn't have to be in the middle. Could be here, whatever. It's just parallel to one of the sides. And this is the sketch. Okay, this is what I have. We're going to express the area of the playground as a function of one of its dimensions, x. We call one of the dimensions x. It could be this. You can call this x. Or I could call x the other one. Doesn't matter. It's going to change a few details throughout, but it's going to give you the same answer on item B at the end. So I'll call this x, and I'll call this y. I'll do a square y like that. Okay, so what is the area then of the playground? It's base times height, or length times width. However, when referred to those dimensions, it's x, y, right? That's the rectangle, so that's the formula for the area. Now, we have to use the information that we have a limited amount of fencing to make this look a little nicer. Right now, I have a function of x that includes both x and y, and that's not good. I just wish I only had x here, not y. So get rid of this y by using what I just told you, using the fact that the amount of fencing is limited to 1,000 feet. So if I write that, so the amount of fencing is 1,000. So let's count. So I have one x and then another x. So that's two x's. And then I have 1, 2, 3 y's. And that equals 1,000 feet. Remember that I want to find y so that I can replace it back here. So I want to find y equal to something. So I want to solve for y. So move the x over. Divide by 3. So maybe I could keep it like this. It's fine that way. That is y, so I'll take that and I'll replace it back into the area formula. So a of x is 1,000 thirds minus 2/3 x, distributive property, and I'll also reorder, put the x squared first. So a of x equals minus 2/3 x squared plus 1,000 over 3x. So that is my formula. I'll move it down a little bit just so it's clear, and I'll box it out just so you see. This is the area in terms of x. Once you decide what x needs to be, y is automatically determined by the amount of fencing that is left, the amount of fence that you have. Okay, so that was A. On B, we just want to optimize this. We want to maximize A. This is a concave downward parabola. Looks like this, the graph. So there is a max for sure at the vertex. So you want to find the x of the vertex first. The x of the vertex is minus b over 2a. You either remember that or you draw, find the two zeros, and average them both to find the middle. Either way is fine, but that's the idea. The two zeros added together are minus b over a, and then you divide by 2 to get the average. The number in the middle, that's the x of the vertex. Whichever way, either remember the formula or draw and find the zeros. You should find the same value. And in this case, you're going to get minus 1,000 over 3 divided by, so 2 times a, so minus 4/3. When you divide fractions, it's equivalent to multiply by the reciprocal of the other. So you can cancel the 3's and get 1,000 divided by 4, which is 250 feet. So that is x. I want to find y now, but that is pretty simple. I know how much fencing is left, so I only have one choice for y, and I find that by doing 2 times 250 plus 3y equals 1,000. So 3y equals 1,000 minus 500, right? This is 500, I divide. So y is 500 divided by 3. We're rounding to 2 decimals, so I'm using my calculator here just to be safe, and that's 166.67. So these are the true dimensions. What could happen if you chose at the beginning, if you said x was this height, if you switch x and y, switch their places and say x is the vertical and y is the horizontal in my drawing, what will change is that you're going to get x equals 166.67 and y equals 250, but that doesn't matter because I want the dimensions. Right? All that I care about is that you have those true values and that you clearly showed me how you need to find them, how you found them actually. Okay.